All right, let's start looking at our first few antiderivatives. So you'll remember when we were learning derivatives that there was a very helpful rule called the power rule. And what the power rule said was that if I have a function that's f of x is equal to x to the n, then that means the derivative of x, of our function I mean, is equal to n to the x n minus 1. One thing that's helpful about integrals is since they're essentially the reverse of derivatives, we can have rules that are kind of the mirror image of these rules. So here's the antiderivative rule. The antiderivative, capital F of x, is equal to, well, and again, let's assume this, what we're doing now is assume we have f of x equals x to the n. The derivative of what is equal to this? Okay, so notice here's my function, here's the function's derivative, but now we're going to go backwards to find the antiderivative. So capital F of x would be equal to the following: x to the n plus 1 divided by n plus 1 plus c. Let's see how this works. What I'm telling you is that the derivative of this is equal to this. Let's see if that works. First off, if we take the derivative of this, the c gets knocked out, which is why we need to include it. We need to show that this is the general antiderivative of this. We talked about that a little bit in the last video. Notice now how if I take the derivative of this with the power rule, the n plus 1 comes down, which would cancel with this n plus 1. Then we take 1 away from the power, which would get us back to x to the n. So this is kind of the antiderivative power rule right here. The derivative of this is this, the derivative of this is this. So that means that this is the antiderivative of this. One really nice thing about doing antiderivatives is that it's really easy to check your answer. Just take the derivative of your answer and see if you get the original function again, and we'll be in great shape. All right? So let's find the antiderivative, or the integral, of x cubed. And remember that integrals and antiderivatives are a little bit different. Antiderivatives is a solution to an equation. Integrals are a summation of a bunch of Riemann sums. However, they use kind of the same idea. So using our rule up here, we can get the answer in one step. X to the 4 divided by 4 plus c. All I did was I just applied my rule. I used this rule up here, I increased the power by 1, divided it by that amount, and then just added c. Notice what would happen if we took the derivative of this. The c would cancel, the 4 would come down, which would cancel with this 4, and this would drop to become a 3, and we end up exactly at x cubed. Let's look at another example. What would be the integral, or what would be the antiderivative of 8? Well, we could use this rule up here again, but this one is a little better to do just intuitively. We kind of talked about a similar one in the last video. The answer would just be 8x plus c. The derivative of 8x plus c, and c can be any real number, the derivative in positive or negative or 0. The derivative of 8x would just be 8. How about the next one? X to the 4/5. Well, just use the power rule again. So what I'm going to do is I'm going to ask myself what would be 1 more than 4/5, and the answer is 9/5. So this would be x to the 9/5 divided by 9/5 plus c. This one's a little trickier because of the fractions, but let's see that it works. We take the derivative of this, the c gets knocked away. The 9/5 comes down in front, which will cancel the 9/5, and then we would need to subtract 1 up here. And subtracting 1 would be the same as subtracting 5 over 5. So we take 5 off of here, which would get us to 4/5. So 9/5 minus 1 is 4/5. So this does work. It's kind of weird to be dividing by a fraction, so let's copy that, flip this. This answer would also be equally valid. 5/9 x to the 9/5 plus c. So on a test, I would accept either one of these answers, but this one's probably a little bit better. Notice again, as the 9/5 comes down, it does cancel the 9 and the 5. Last one in this video, 1 over x to the 5. Let's find the antiderivative of this. It is helpful, sorry, I lost my focus. It is helpful if we write it like this. The integral of x to the negative 5 dx. So This is just like a giant S, this integral symbol. It's not an S, but it's like, this is a better version of it. Sorry, that's not the best integral symbol ever. So 1 over x to the 5 is x to the 9/5. So now let's use that rule. We would increase this by 1 and divide by it being increased by 1. So the answer would be x to the -4 over -4 plus c. Okay, let's see why that would work. We take the derivative. The -4 comes down, which cancels the -4. The derivative also knocks off the c. And then we do -4 minus 1, which would be -5. So that is the antiderivative. It's nice because you can check your answer. Notice that the integral symbol goes away once we've done the antiderivative. So we get x to the -4, or negative x to the -4 over 4, whichever you want to do, plus c would be your answer. Now, as I said, integrals are a little bit different than antiderivatives, but for our purposes, I might use the two terms interchangeably. Just know that if you're speaking very strictly, one is talking about an area of rectangles, whereas the other one is just an answer to an equation. But in any case, it's the same idea. In the next video, we'll do a couple more examples. If you have any questions or you're confused, please send me an email. See you in the next video.